Hey guys, so I just wanted to make a video to go over some of your kinematic practice problems that was posted as an assignment this week on Schoology. So I'm kind of going to skip around because some of them are a little more difficult, but I want to start with one that's a little more straightforward. So the first one I want to take a look at is number 2. So it says Georgia is jogging with a velocity of 4 meters per second when she accelerates at 2 meters per second squared for 3 seconds. How fast is Georgia running now? So the first thing we want to do when we're problem solving, remember we want to pull out all the important information. So I suggest circling every value and every unit that the problem gives you. So for instance, the first thing I'm going to circle would be my 4 meters per second. Then I would also circle my 2 meters per second squared. That should be squared. I apologize for that typo. And then I would also circle 3 seconds. The next thing I want to do is underline what I'm looking for. So we can say we're looking for how fast is Georgia running now. So now that we've identified the important parts of this problem, let's make a list of givens to try to help us determine what these values actually stand for. So the first thing we can see is that Georgia is jogging with a velocity of 4 meters per second. So the first thing I know is that my VI is going to be 4 meters per second. Now it says she's accelerating at 2 meters per second squared. So I know my acceleration is going to be 2 meters per second squared. Then I have 3 seconds, so I can say my time will be 3 seconds. And I'm looking for how fast. So I'm looking for my final velocity, so what the speed she ends up at. So based on our kinematic equations, so this is something new. We're still using all the same quantities and values we've talked about all year: velocity, acceleration, time, displacement, but we're applying them now in equations that show the relationship between all of these variables. So we need to pick an equation that uses VI, A, T, and VF. One thing that I always explain about kinematic practice problems is there's always 5 possibilities that you can have in a problem. So the 5 things that you can always have in a problem, so this is just going to be a little sidebar, is it's possible to have displacement, time, acceleration, initial velocity, and final velocity. So these are the 3 quantities that we're going to have to worry about finding in our physics problems. So we can see here from our list, the one thing that we don't have and the one thing that we are not looking for is x. So we could care less about this x. So we want to pick an equation that is going to not include x, because if we pick an equation with displacement and we're looking for VF, we're going to have 2 unknowns and we're not going to be able to solve that problem. Find an equation that does not involve displacement, but involves initial velocity, acceleration, time, and VF. So the way you use this second column here on this chart is the missing quantity. That stands for the quantity that we're not worried about and that we're not looking for. So we already stated that was displacement. So if you see this first equation does not involve x. Remember, x is displacement. So we can see this equation has VF. So if it's not stated there, that's VF. This little 0 is going to be initial velocity. Sometimes in physics they use different symbols to signify things, but that V is just VF, VI plus AT. So we're going to pick that equation. So we're going to say VF equals VI plus A times time. So we can see now that we're already set up to solve for VF, and we don't have displacement. We're not worried about it, so we know we picked the right equation. So I'm just going to plug in my values because we see everything's in meters and seconds. We're going to say 4 plus 2 times 3. So I just got that off my list of givens. So when you guys put that in your calculator, which you may be able to do this without a calculator, we're just going to say 4 plus 2 times 3. So our final velocity should just be 10 meters per second. All right, so let's take a look at number 1. So like I said, I'm just jumping around. But number 1 says, what is the displacement of a plane that experiences uniform acceleration for 66 meters per second to 88 meters per second in 12 seconds? So I'm just going to, again, circle any value in units that it gives us. So we're going to circle 66 meters per second, 88 meters per second, and also 12 seconds. And then I'm just going to underline what I'm looking for. So now I'm looking for displacement. So an easy way to kind of determine what we have and what we're looking for and what we don't have is, I always suggest just write out the 5 possibilities. So I'm going to write out X, T, A, VI, VF. And then I'm just going to fill in my list this way. So then I can say, I know it says acceleration, but we know it's in meters per second, so we know this has to be a type of velocity. And since we're going from this velocity to this velocity, we know our 66 is going to have to be our initial velocity. Our final velocity is going to be our 88, because remember we're going from 66 to 88. Our time will be 12 seconds, and we're looking for displacement. So now that I've written out all 5 values, I can now see what I don't have and what I'm not worried about. So I'm just going to put an X through acceleration. So I want to pick an equation that does not involve acceleration. So if we go up here and look at our chart, we're going to look on the side that says missing quantity. So we see there's only one equation that does not involve acceleration. So we're going to say that X is equal to 1/2 times VI plus VF times time. So remember, whatever we don't have and we're not looking for, it's irrelevant. So we have to pick the equation that doesn't involve it. So now what we're going to do is in our calculator, we're going to plug in our values. So we can say X equals 1/2 times 66 plus 88 times 12. So I'm just going to do 0.5 times 66 plus 88 times 12. And so we're going to get 924 meters. So 924 meters. So let's take a look at number 3. So number 3 states, an airplane accelerates from rest down a runway at 3.2 meters per second squared for 32.8 seconds until it lifts off the ground. What is the distance the plane travels before takeoff? So I don't want you guys to get hung up on the word distance, because in these equations, if it asks for distance or displacement, they're going to mean the same thing. So the first thing we see is we want to circle any value in unit it gives us. So we're going to circle 3.2 meters per second squared, 32.8 seconds, and then we're going to underline what we're looking for, which is distance. And also I'm going to circle a key word in here where it says rest, because I know if things start from rest, that's going to give me my initial velocity. So I'm just going to write out all 5 possibilities that could be in this problem. Now there's not a certain order that you have to write these in, and it doesn't matter what order you write them in, just as long as you know that there are 5. So now we're just going to look at our problem, and we are going to make sense of what it gives us. So we can see it says it's starting from rest, so we know our speed when we start is just going to be 0. So by VI, I'm just going to write out 0. It also gives us a value that has meters per second squared. So there's only one thing we measure as meters per second squared, and that's going to be acceleration. And then it also gives us a value with seconds. We know time is the only thing we measure in seconds. And we're looking for distance. So now looking at our list, we can identify what we don't have and what we're not looking for. So we could care less about VF. So we have to find an equation that doesn't involve VF. So let's scroll up to our chart, and we're going to look in the missing quantity side. And we're going to see that, remember, just a V by itself is going to signify VF. We can see there's only one equation that doesn't involve VF. And that's perfect because we don't care about it in this problem. So we're going to write out X equals VI times time plus 1/2 AT squared. So remember, we're looking for X. We can see X is already isolated. And so now we can just plug in our values. So I'm going to say X is equal to 0 times 32.8 plus 1/2 times 3.2 times 32.8 squared. So one thing people make a mistake on is the time is the only thing that's squared in this equation, okay? The A and the 1/2 have nothing to do with the square. That's just our time. We already know that 0 times anything is going to be 0, so that part of our equation isn't going to matter. So in my calculator, I'm just going to put in, we're going to say, we'll put in 1/2 times 3.2 times 32.8 squared equals, it's going to give me a value of 1,721 meters. So the key for solving these problems, there's 3 problems left, is identify what the problem gives you. I would start by writing out a list of all the possibilities. Remember, there's 5 possibilities that you could have in this problem, or 5 quantities, I should say, you could have in this problem. Displacement, time, acceleration, initial velocity, and final velocity. Start by filling in your list based off your problem. Identify the one that you do not have, so the problem didn't give it to you, and the one that you're not looking for. So the one that we don't care about, we're going to find our equation that doesn't involve that quantity. So write out all the possibilities, determine which one we don't have and which one we don't care about, and pick the equation from there. So I will go ahead and post on Schoology the other 3 answers to the problems, but I want to give you guys an opportunity to try to work on those on your own.